I'm going to go through the core concepts here as quickly as I can using this example diagram. This diagram loosely represents something that you'd need on like an e-commerce website or something like that. However, you can model pretty much any software system using these building blocks. So the first one I'm going to go through is an enum, or an enumeration. And that's just effectively a list of fixed items, or a list that doesn't change very much. So in this case, a list of countries, right? The next concept, the next three concepts are effectively the most complicated out of all of this. And it gets a lot easier after that. So just bear with me. So the next one is an entity. And that's effectively something in your software system that you want to track separately from something else. So let's say, for instance, you've got a list of customers in your software system where John Smith has a first name and last name and other properties, like a date of birth and so on. And you want to track John Smith separately from Susan Baker, so they'll have separate identities, okay, or ID numbers. The next concept is a value object, which is basically a complex object made up of multiple different properties that you want to be able to model. Now, a value object doesn't have an identity of its own. So, for example, an order, think of an invoice or something like that, will have an identity of its own in that each invoice is separate and different. But on that invoice, you'll have certain line items, and you just want to be able to record the name and price and quantity of those line items. But you don't really care about each line item after that. Okay, and then basically a cluster of entities and value objects that are very tightly related to each other is called an aggregate. Okay, an aggregate will have a root entity, and that root entity will give the aggregate its name. So in this case, currently our root entity is set to customer, and therefore the aggregate is named customer. But if we change it to address, it would change to address, right? Now, the root entity is really important in that that's the only thing that the rest of your software system can interact with, and the business rules will be governed around that root entity. It's consistency boundary, right? Okay, moving on. So next, we would like to be able to model all the behaviors our users in our software system can do, all the actions and so on. And we do that by adding a user to the diagram. Users will have certain roles that they would be assigned, and they can have multiple roles, obviously. In this case, our system has managers, sales clerks, and an owner. We also have special types of users in that we might have guest users that aren't authenticated on the system, as well as authenticated system users, basically people who have logged in. Okay. In this case, in the software system, anyone who's logged into the software system can issue a command to place an order. When placing the order, there's dependency on a third-party API, in this case provided by MailChimp for their email API. And that API lets us send emails through to customers. So in this case, when a customer places an order, we'll send a confirmation email through to them. We then move on to the next concept, which is a domain event. A domain event will always happen after a command is issued. And a domain event effectively captures the history of our software system. So this is by far the most important thing on our software system. And it's the thing that you really need to spend the most amount of time thinking about and modeling, right? Because you really shouldn't be changing the properties of a domain event once you start recording them in the system, okay? If, let's say, after 6 months or so, you find that you've modeled this event incorrectly, let's say, for instance, you started by capturing just the customer name as a property, what you could do is use a transform to transform that domain event into a different shape. So in this case, we want to transform from order placed version 1 to order placed version 2. And maybe we are going to have, capture the first name and last name of a customer instead of just the name. And then what we can do is effectively retire this old event and then just use the new event from that moment forward, right? Now, when we are performing actions on behalf of users, stuff could also go wrong from a business perspective. So in this case, let's say someone tried to place an order, but items were out of stock. Then we get a error event happening, okay? And an error event captures all those details. What we could do for basically any event is we can have a policy that gets run when that event occurs. So in this case, our error event occurs, and we have a policy to restock items when they run out. Okay, then effectively you have an event coming into a policy, and then the policy calls a command from that point onwards. So we have a order items command that gets executed, and in this case, it effectively just adds a row onto a Google Sheet, and then someone can look at that and order items out of band. Okay. Again, we have another domain event that happens, and let's say we want to add a delay of 5 minutes or however long it is. Before we check if the items that were ordered came up to more than €1,000. If they did, then we want to run another command saying we want to inform the boss, and here we call over to a different API integration now by a company called Twilio, where we want to send out an SMS. Okay. Here we have a sticky note that we want to just effectively talk to our dev team about how we're going to go about doing this, and so on, right? Our next concept is a timer event, a time event. Effectively, you can set these up to be create your own events. Here we have just a few. So like you might want to have a timer that goes off hourly, daily, weekly, so on, or your own special time events, like let's say Black Friday or Christmas or something like that. You can set them up separately. When that happens, or someone calls a webhook into our system, we are going to now trigger another command to run here where we're going to preemptively order items. Now we could use another third-party integration, in this case a AI LLM, that can maybe look over our items and see what's the most popular and predictably order items for us, right? That's completely up to you on how you design your own software system. Okay, then we're almost done. All the events can be fed into our read models, and our read models are basically just a bucket for all the data that we need to be able to write queries. Okay. And you can see the read models can look differently from the aggregates. We can model it however we need to make our queries efficient. In this case, we're going to create some labels for deliveries. Our read models can raise notification events, and we might use those on our user interfaces and so on to update the pages. Notification events are like fire and forget, and we don't store them. So yeah, that's that. And then the last concept really is a query. Queries get run against specific read models or aggregates. And they get performed by either certain types of users or AI agents. So in this case, query, AI agent. And yeah, effectively AI agents just let you know that this could be performed by some sort of AI thing. So maybe use this with caution. And that's it. That's all the concepts that you really need to know. And you should be able to draw your own diagrams from here.